All right, so hello, welcome everybody. I'm just gonna share my screen here now. All right. So welcome everybody to the first Graph API training workshop. Thank you for joining us today. So a reminder of today, or an introduction to today's agenda if you haven't yet seen it. So today's workshop will last an hour and a half up to 2 hours, depending on if we're really deep in some conversations and exercises. Of course, we can continue. So we do have the 2 hours booked, but it's an hour and a half to 2 hours if depending. So we'll start with an introduction, giving an overview of API architecture, basic concepts and terminology, core features of the Graph API, and then Q&A. And then we'll move on to the hands-on practice, which is we'll work with some real-world examples and use cases, and then the problem-solving clinic, so troubleshooting issues and addressing specific requests. So that's the general overview for today's session. So your trainers today is you have Alexios Symeonidis, a software developer at OpenAIRE, and Miriam Baglioni, who is a data engineer, curator, scientist, and data scientist at DCNR, and she's a manager of the periodic dumps of the OpenAIRE Graph. So some guidelines for today. So we ask you to please keep your microphone muted while not speaking to avoid any background noise. Questions about the introduction section will be addressed during the Q&A, and then questions about the use cases and exercise can be asked at any time during those exercises. To ask a question, you can either raise your hand using the raise your hand feature, or ask your questions in the chat. And then during hands-on practice, general interest questions will be addressed in the main session, but if you have specific issues, we can handle them separately in a breakout room. Just check here in case there is something else. Yes, the workshop will be recorded. So will be recorded because we can upload the exercises and the presentation to the OpenAIRE Graph website. We have a training page, so those who aren't able to participate, because again, seats are limited, so we can probably help and guide everybody through the exercises. So the session is recorded and will be put on the OpenAIRE Graph website. If you do not wish to be recorded, please let us know, and then we can edit. If you pose any questions or anything, we can edit those out of the recording, no problem. All right, so with that, then I will hand the floor over to our trainers. And thank you.
Yeah, thank you, Alan. Let me share my screen. Yeah, thank you. Hello, everyone. Thank you for joining for this to this training. And yeah, today I'm gonna show you how to use our Graph API. So yeah, from your answers, I saw that you are familiar with these concepts, so it won't be something complicated to you. So yeah, let's get started, and let me share my presentation. Do you see my screen?
Yes.
Okay, perfect. Okay, let me minimize this. Okay, so yeah, my name is Alexios. I'm a software developer at OpenAIRE. And yeah, as I said, I will try to explain to you how to use our Graph API. So before diving into the examples to these exercises, first I would like to give you an overview. What is the graph? Explain some basic concepts. Although I saw that you are familiar, but some of you are not. So I think it's a good idea that everyone is on the same page. So just a brief overview. So graph, what is it? Well, the short explanation is a database. This is the persistence layer where we store all our data, and where do we get this data from? You can see here on the left side of this picture that we collect all this data from external sources, and there are multiple different external data sources, like data repositories, software repositories, author registers, publisher archives, journals. There are many of them. So we collect all this data from these external data sources, and we run some workflows in our backend system where we process this data. We transform it, enrich it, deduplicate it, clean up all this data so that it's valid, it makes some sense. And after that processing, we persist this data into our graph. We index this data to our graph. Technically speaking, we use Apache Solr. So why? Because it is open source. It is designed for searching. Basically it's a searching engine, and it has a great community. You can find very easily support, documentation. It's available, so that's why we use it. So we keep the data on this level, on this layer on the graph, but somehow the public, the research community has to interact with this data. They have to get this data, right? So that's where this Graph API comes to. We needed to design it, right? So it's responsibility to expose all this data. So this is a REST service, and where we expose all this data, and through this service, all this data is available to the public, and anyone like this, anyone can interact with our data in any way they want. Like they can integrate this service into their existing services. So like, for example, in their web portals, in a mobile application, in a desktop application, whatever, it is up to you how you are gonna consume this API, integrate it in your existing systems. So yeah, it is a REST API. So what does it mean? Well, REST means an architectural style. It uses HTTP. That's the brief explanation of it. So existing, you don't need to reinvent the wheel. You use existing protocols. HTTP, it's a web protocol, right? So you use the existing protocol to expose your data. And API means application programming interface. So yeah, it's not a UI. You need some technical understanding, right? So to use it, but it's nothing complicated. I will show you that. Yeah, we use HTTP protocol, and the HTTP protocol has several methods. The most common ones are get the existing data. Post is to insert a new record. Put is to update, and delete is to delete data from your database. So yeah, I can show you an example of a get method. So if I click on this request, let me open up So you already see that I made a request from my browser, which is a desktop application, right? So let me reload it. So yeah, here we can see that it's HTTP method, and the request method is get, and we got this response. And this response is in JSON format. So yeah, pretty simple format to understand. It's a key value format, and it's a commonly used in like everywhere. It's the format that dominated, and yeah, it's language independent. You can use it to yeah to send a request and to get a response back. All this is done in the JSON format, as we saw in a real example. Yeah, the main stack that we use in our service is we use Java version 21, Spring Boot framework. It's a web framework. Solar client, because as I said, we use Apache Solar for our database. The server is Solar. So in order to communicate with this database, we use a Solar client. And Swagger is just a simple UI that generates it's simple UI that exposes renders the endpoints and shows the data schemas of each endpoint. And I'm gonna show you in a minute this UI. Okay, so yeah, how to use it. So that means we have to focus on this diagram, on this picture of the whole diagram that I showed you. Yeah, how to use it? Well, first I would say you should start from the documentation. Don't go directly, although if you are a developer, you can already start interacting with the Swagger. But if you are not familiar and you want to, you know, get into the context, please start from the documentation. So in this, yeah, where we explain all the details about this service. So there are many different ways to make requests to this service. As I showed you, from a browser, you can make a request from a terminal. Let me show you that. Hold on. So yeah, here I have already a request saved in my history. So yeah, I used a curl command. So you can use it either from terminal or browser or terminal or any software that that understands HTTP protocol. So it could be Postman, which is a desktop application. Let me show you that also. So here, for example, the same request. This is a desktop application, you see, and did I click on it? Yeah, so pretty much you see the same information, you see the response, you see the status, 200, it's okay. You see the request and the request parameters. So yeah, that's another way how to interact with this service. And also you can you can make requests from a script, like from a Colab, online service. So yeah, this is, I will show you, this is the simple one. So the same request. So if I run it, this is a Python script. I use Google Colab and it's executing. And yeah, again, I got the response. And this is the one that I showed you here. Yeah, again, this is Python script. It's more complicated, has many scripts, many steps. And yeah, it does some more complicated work here. And the final result is like this. So you can see all this result like in a tabular format, you know. And yeah, by the way, all these links will be available to you. And so you can play around with them and yeah, experiment, modify them, and yeah, make all these codes on your own.
If I can add something on
Yes.
that, yeah, this is an example, very little, regarding the University of Bologna, where we show very basic analysis that can be done on the data got from the OpenAIRE API. That is, we use the API to select the organization we are interested in. We get the identifier for that organization, and that we use that identifier to collect all the results published in the last year, between June 2024 and June 2025. Then on this set of results, we do some analysis. How many of those are publications? How many of those are data sets, software, other research product? Which is the accessibility? Which is the best access rights for the publication that are open? Which is the color? We selected the journals where the publication were published. And in the last paragraph, we tried to show something more complicated to, let's say, show the number of collaboration between the University of Bologna and the other organization present in the results that we have downloaded. Just an example, very basic, to show how it is possible to programmatically analyze the results we get from the APIs. Thank you, Alexios.
Great, thank you, Miriam. Okay, great. So yeah, we saw all this. So we saw that I just wanted you to understand that there are many different ways to interact with this API. So no need, since it's REST and we use HTTP protocol, there is no need to install something on your local machine, nothing. So that's the beauty of it. And yeah, here just a simple example of again of this command, of a curl command. So this is the curl command, this is the get method, and this is the endpoint, and these after this question mark are the request parameters. And yeah, accept application. Yeah, the data transfer format should be JSON, but if you omit it, it's the default. You know, it's the default command. So yeah, and the next one. Okay, so we support, yeah, our endpoints support versioning. So every time we make some changes, we update the existing models or introduce some new endpoint, introduce some new data models. All this will be done on a new version. We will create a new version for that. Don't be afraid. The old version will exist. We will deprecate it, but it will be still working. But from your side, you have to try it, as soon as possible to switch to the new one, because it's more reliable, you will get more data. So yeah, try to use always the latest version.
If I can add something also
Yeah,
there.
sure.
We decided to prepare another access point for research products, because in the first version, we just shared descriptive information of the metadata of the entity. So the title, the authors, the various materializations that can be, let's say, deduplicated into one result. What was missing was the normalization of the result that allow to find information also for affiliated organizations, projects that maybe fund that specific result, the data source we collect this information from. You could have got this information also, but you would have had to perform a lot of queries to the API. So we thought it would be better from a usage point of view to extend the results, including also this other information. Whichever information you find in version 1, you will find also in version 2. But in version 2, there will be the affiliated organization, the related project, the result, the community the result is relevant for, the data source we collect the result from. Thank you, Alexios.
Thank you. Okay, by the way, in order for you not to get confused, I marked the old version, I marked it as deprecated. So yeah, if you open it up, this one, you will see a short description. So it's deprecated, please use version 2. And it's not, it's on my local, I haven't deployed this change to our beta and prod environment, and next week it will be available. So yeah. So I said beta. Yeah, we use two environments. It's the beta where this is, from my local, the developer deploys first to the beta environment, and this is where we test. It's a testing environment. It's not stable. Changes happen without notice. I mean, notice to the public. But you can use it because it will have the latest updates. You can still use it, and for us it's good if you use it, because if you see something and you let us know, that will be very helpful for us. But don't use it. Don't integrate this beta API in your production system. Use this one. So this is the production. So you can see here the difference in the URL. So the prod API is stable, and you can use it in your prod environment. And here is what you already explained, right, Miriam?
Yes. This is an overview of the entities that can be found in the graph. The person entity is not an entity now in the API, but can be derived from the authors that are in the results. All the other elements are entities, and you see they are all interconnected. So version 1, as I said before, shows descriptive metadata of the research product, while version 2 extends version 1 by including also other, according to us, relevant information.
Okay, great. Okay, so this is, okay, let's go to the examples. So this is,
maybe, sorry to interrupt, Alexios.
Yeah,
Maybe this is a good time if anybody has a question on this first part before going to the example. This is we may take a question now. You can raise your hand or type in the chat. We wait for 1 minute so that people can think about it.
Yeah. Actually, let's do it from the Swagger here.
Perfect. And we do have one question in the chat. What is the limit for requests?
The minimum request. What
the limit for
request? The limit. Well, we use pagination Sorry, limit for request. What do you mean? I don't understand that. The rate limit.
Of the
Okay.
request.
Yeah.
Or you can, it is in any case in the documentation. I can find the
Yeah,
link
yeah, yeah.
and post it here, and you will
I don't remember. Yeah.
Yeah. Because there's a different limit for authenticated and unauthenticated.
Exactly, yeah. To get like unlimited request, you have to sign up, create an OpenAIRE account, and yeah. But for those who are not authenticated, to be honest, I don't remember. It's somewhere, yeah, somewhere in the documentation. You know, for this, this is not Graph API's responsibility. It's not, it's all this happening on API gateway level. So that's why I don't remember all these details. Sorry, but you can find it in this documentation.
Here, yes, I'm copying, pasting the link here, which is the page on the authentication limits. Just gonna put in some text so we know this is referring to.
Okay, so this is the Swagger. We are gonna make a request mostly from this UI. And here you can see that we have already version 1 and version 2. Version 2 is only one endpoint, research products. Yeah, as you can see here, version 1, I'm gonna deprecate it as I showed you. I'm gonna push it, deploy it next week. So yeah, it will be more visible to you, so you don't get confused. So jump to the new version. And yeah, let's go to some examples. What is the first one? Yeah, research products. Let's make a request with parameter search, yeah, knowledge graph and type publication. Let's do it by hand like this. So this is the endpoint. Knowledge graph. Publication, right? Yes. Sort by relevance. And sort by is somewhere. But yeah, this is the default. But you can see here, you can sort it by all these fields: publication date, date of collection, influence, popularity, citation count, impulse. Okay, so if I execute it, I should get a response. Yes, I got a response, and you can already see here, you can already see here that, yeah, the curl command, so you can copy it and execute the same command in your Postman, for example, or copy this URL. It put all these parameters in this request and execute it from, let me try from another browser, because I use this is Firefox. And it shows it in more like a nice way. So here we see the results. This is some metadata, first page, page size, and some max score. It's some, the searching algorithm. Not you should focus on this part, the results. So this is the data that you should be interested in. So yeah. Okay, so do the same, but rank results based on descending citation counts. Okay, sort by, okay, the same thing, but sort by another field. Well, you have to, like, it's difficult to understand now to see the difference, but let me check. No. Well, it's still authors, right? It's sorted by.
The results are ordered differently. You see also the
It's
orders
but
is
the thing is,
different.
it's difficult to understand it by scrolling down, by looking at this JSON. But it works. You have to trust me. Okay, another example. If you have questions, interrupt me, please. So, yeah. So this one, first find the identifier of the organization of interest. So organization, so this is another endpoint, organizations. And we search for, let me click on it. Well, it should be Athena Research Center, I think. Not innovation, but let's see. So let's go back to version 1. Organization. Research Center. Yeah, and we got this result. And the search, by the way, here the Boolean expression operator is the default is OR. So yeah, because I remember from the last session someone asked, and yeah, the default is OR. So this or this or this. So if you find in any record this values, then return this in a response. Okay, so and the next one is then search for the most cited publication related to the organization. So that means we have to find from this response, we have to find the organization ID, right? So let me again run it from Firefox because it's more beautiful. So organization.
It is called ID, just ID.
Just ID.
Yeah.
This one should be.
Yeah.
Okay. Oops, sorry. Okay, so I got this one, this identifier, and if I make a request, yeah, first I have to replace this placeholder. Yeah, let me put it back to. So we got all these results. Okay, so yeah, so we are using in our APIs, we use pagination, and we use two kinds of pagination, offset pagination, where, in the UI, if you see like page numbers like this, 1, 2, 3, this is an offset pagination. If you see, for example, I saw it on the Nodo side, like you see results, you scroll down and you see this button more to fetch more results. So this is a cursor-based pagination. So we offer both, and it's up to you to use whatever you want, the first one or the other one with the cursor. So here, for example, this is organization. Let's see if it's got page 2. Page size, the default is 10, and the maximum, I think, is 100. So here you see we are on page 2. And if I use cursor pagination, let me use better the research products. So, oh, sorry, I have to click on this button. Okay, so the default, the starting page is asterisk. Initial values, yeah, I describe it here. And if you execute it, you will get a response, and the next cursor will be this one until it reaches to the end, you know, so this is like with cursor, you can use it when you want to fetch, you know, a lot of results, more than 10,000 records. So yeah, if I use it, the next cursor, I use it here, I will get another one. So this value always changes. If we reach to the last page, the next cursor will be null. So yeah, we use pagination. Yeah, as I showed you, offset pagination, cursor-based pagination, two different types to get results. Okay, and here another example. First, find the identifier of the project of interest, which is this one, grasp OS. We got this response, very short response. And then return its recent publications and get the subject, e.g. field of science. So do we see an identifier here? This one, right?
Yes, yes, it is the identifier.
Yes, and if I again replace this placeholder, identifier. So yeah, the way to interact with it, it's very simple, but you have to understand the data. And let me show you how can I remove this. Oh, come on. You have to understand, and that's why first you need to read the documentation, right? And you have to understand these data entities, and then you have to understand all these request parameters. Like you have this keyword-based search, you have main title, the description, you have many different request parameters from to publication date. So by setting a different request parameter, which is a filter, right? You filter out, the more precise is your request, the more precise will be your response, right? So yeah, you have to know your data. Because as you saw, the interaction to make a call is it's nothing complicated. Even if someone who doesn't have a technical background, I mean, it's very straightforward to learn all these commands. Okay, do I have any other? Yeah. Get the citations of a given publication. So another request with, why don't I get, okay, it's a bit slow because here it fetched. Okay, so Let me make this. Let me show you from Swagger this. Oh, here it is encoded. This PID is encoded. I'm not sure if it's gonna work, but let me try from
You have
Swagger
to replace %2f with slash.
with
Okay.
/.
Yeah.
Okay, let me try to do that. So it's links, right? So let me close this one. Target PID. Percentage, and this one, right? Like this.
The F also you have to replace. Remove the F also.
Ah, okay, okay. Yeah, so we got the same response. Which means for this ID, target ID, we got the citations, right?
Have you added the relation type?
Sorry?
Have you added the relation type?
Relation type.
It should be relation in the...
Which one should be? Relation
Type.
sets. Yes, sorry.
Capital C.
It's yes. Case sensitive. Maybe we should change that so it's not case sensitive. Okay, so we got this response. Okay, so do we have any questions or do we any request that we want to run together, like any example?
If you go back with the relation, I think it is important to show that the link, the relation, is not just the two identifiers, one citing the others, but there is also some information that is relevant for the entity. So, for example, the title, the type, the instance type, when it was published, who are the authors of both the results that are linked. We were, let's say, we have to add here the provenance of the relation because there is not there, and we have to. So in the near future, you will have a version 2 of the result of the links containing also who is the provider of the relation. So if we harvest it from who we took it, otherwise, if it is inferred by OpenAIRE, it will be the provenance will be of the relation will be OpenAIRE.
Any other questions?
So in that case, I guess we can wrap it up. As always, we'll make the recording and slides available once the recording is all uploaded. And as always, you can reach out to us again, either via the help desk or user form. So we'll wish you all a good weekend. Thank you so much again, Alexios and Miriam, for the presentation, and everyone for your participation. Thanks. Yeah, all right, we'll wrap it up there. Have a good day, everybody. Bye.
Thank you. Bye.